Hi, Assalamualaikum and good evening everyone. So today we are from Group 8, AZIM, RUBEN and I, NAIM, will present the topic of supercontinuum generation. Next. So what is supercontinuum generation? Supercontinuum generation is a process where laser light is converted to light with a very broad spectral bandwidth and with the very low of temporal coherence. So this is because the spectral broadening is usually accomplished by propagating light pulse through a strongly nonlinear device. So for the example, one may send an intense ultra-short pulse through a piece of dark glass, but however, we can still send the pulse with much lower pulse energy through an optical fiber having a waveguide structure which allows for a long propagation length with small effective mode area. So next I pass to Azim about the working principle of the supercontinuum generation.
For the next part, let me explain about the working principle of supercontinuum. Firstly, this process occurs when the laser light is turned into light with an exceptionally broad spectral bandwidth. The process occurs. The light pulses are sent through a substantially nonlinear device to achieve spectral broadening. For example, a piece of dark glass can be used to pass an instant amplified ultra-short pulse. Optical fiber may also be used to send pulse with significantly lower pulse energy by having waveguide structure which allow for long propagation length with small effective mode area. The very broad spectra may be achieved even with relatively modest input level. It is important due to their unusual chromatic dispersion properties, which allow for strong nonlinear interaction over a substantial length of fiber. As a result, we can see the laser rainbow appears.
So for the physical mechanism, so I'll explain about it. So first of all, we should know how supercontinuum works, where it is a process where laser light is converted to light with a very broad spectral band. And secondly, to make a supercontinuum in optics, a supercontinuum is formed when nonlinear process act together upon a pump beam in order to cause severe spectral broadening of the original pump. For example, using a microstructured optical fiber and highly dependent on chromatic dispersion as for example, length of fiber, the pulse duration, the initial peak power and the pump wavelength. For the Raman scattering and 4-wave mixing can help when the pump is picosecond or nanosecond pulses. The resulting noise characteristics can also vary greatly depending on the parameter range. The process is quite predictable in some instances, such as when self-phase modulation is the dominant mechanism and the dispersion is typical. Strong Raman gain is a spectral region where the power spectral density is not yet large and can cause significant noise. A highly nonlinear fiber with a small effective mode area and a good chromatic dispersion properties is preferred for the supercontinuum to occur. As a result, for the research of such systems, numerical pulse propagation modeling is required. I think that's all from me.
Okay, so we have know what is supercontinuum generation and how does it work, and also the physics mechanism in it. So now we go through the application. So there are lots of application through the supercontinuum generation, but however here we put the three application that has in the supercontinuum generation. First is the spectroscopy, second fluorescent microscopy, and the last is ultrafast amplifier. So these three is the some types of application in supercontinuum generation. Next. Okay, so for the last in a conclusion, to conclude what is supercontinuum generation is, supercontinuum production is a technique for converting laser light into light with a very high spectral bandwidth, poor temporal coherence, and very broad continuous optical spectrum. Supercontinuum light sources are often employed in applications that need light with a large optical bandwidth but strong spatial coherence, which allows the light to be approximately collimated and focused. So that's all from us. Thank you.